Welcome back to this exam hack series for A-level paper 1 maths, pure maths. And like the previous videos, what we've been doing is that we've been picking apart each question and basically saying, look, they're going to ask a question on the binomial series, so let's pick that question apart. How can they ask it? In this video, we're going to be tackling the vector question, and they ask it every single year. They ask a question on vectors. So what I've done is I've gone through many past papers and looked at all the different ways that they can ask you a question on vectors. And we've got what they can ask you on, which is what I call the fundamental content of the question, and ways in which they can ask it, which is just figured out by doing lots and lots of questions. I really want to get that through your head, is that if you want to do well in exams, you have to practice questions. Don't worry about learning all the content. That's great. You can do that if you want. But if you want to get good marks, you practice doing questions, how they're asking it and what they're asking on. And that's exactly what this series does for you. This series will get you good grades in exams. That's it. Okay, so before we start, download this worksheet. This worksheet is quality. So you've got the fundamental things. So after I went through all the past papers, the fundamental things that they only ask on is these few things, which is on the worksheet. And then we've got examples. All these different examples of exam questions and how they can ask it on that fundamental content. And I've answered all of them for you. So you've got all of my solutions here. So just download that and go through that, and after you finish, you'll be an absolute whiz at this type of question. And when it comes up in the exam, you've done it so many times, you're going to be so confident in answering it, and getting 100%. Right. Anyway, let's get into it. So the fundamental content of this vector question. So you can see here lots of examples. This is a vector question, this is a vector question, this is a vector question. But all they're really asking you on is a few things. And those few things, one of those things is the unit vector. They will ask you on the unit vector. And the unit vector, like I explain in my worksheet, which you should download, the unit vector is simply this. If you have a vector, and you should have looked at this stuff in class, let's say you have a vector u. Usually they write it like OA or something, but it's just a vector u, and let's say it's got components x, y, z, and a vector is just some thing with a length and direction in space. So this has the components x, y, z. So this is u. The unit vector of u, which I call u hat, is simply this vector in the same direction as u, but with a length of 1. That's it. So the length of the vector u is the magnitude of u. So the length of this vector u is magnitude of u, which is this, which you should have seen in class. And the magnitude of u is just going to be x squared plus y squared plus z squared square root. And that just comes from the Pythagoras' theorem. So if you want to go away and just understand, you should understand where these come from and understand them, because they ask on these fundamental equations. So the unit vector is just a vector. So the unit vector of u is just a vector in the same direction as u, but just with a magnitude or length of 1. That's it. So yeah, okay, let's do a quick example. Let's say that you had a vector OA, which equals 1, 2, 3. Well, the magnitude of OA is simply just 1 squared plus 2 squared plus 3 squared, which equals 1 plus 4 plus 9. 1 plus 4 plus 9, which equals 13, so equals square root of 14. So the magnitude of OA is the square root of 14. The unit vector, so you have this thing, OA, this vector. The unit vector is going to be OA, the vector OA, divided by its magnitude, which is the magnitude of OA. Because that's the vector in which, if you divide something by its length, that means it's going to have a length of 1. If you have a stick of a length 10 and you divide that stick by 10, you get a stick of length 1. So your OA is going to equal this, which is 1, 2, 3, divided by the square root of 14. So your OA is 1 over the square root of 14. You know, that's your OA. And you can write it like this. You can bring it in. Ooh, if you want. 3 over the square root of 14. So that's unit vector. The second thing that they can ask you on is finding angles between vectors. And you do that using something called the scalar product, which again you should have seen in class. And the scalar product is just a way to find the angles between vectors. So if you have two vectors, u and v, well, the angle between those two vectors can be found using this formula. That's it. And you know how to work out the magnitude. And this is called the dot product, which you should have seen. So let's say, again, you had, I don't know, let's say you had u equals, you're going to see an example of this in a minute, 1, 2, 3, and v equals, let's say, 1, 1, 2, I don't know. Then the angle between them, cos theta, is going to be equal to the dot product of these two, 1, 2, 3, dotted with 1, 1, 2, which, using this formula, which is just 1 times 1, 1 times 1 plus 1 time plus 2 times 1 plus 3 times 2. 3 times 2, which equals 1 plus 2 plus 6, which is 9. So this equals 9, the dot product, over, well, we already found this is the square root of 14. And this will be the square root of 1 squared plus 1 squared is 2, plus 4 is 6. Right? So then if you wanted to find theta, all you do is you just, cos inverse of 9 over the square root of 14. And you just plug that into your calculator and you'd get some theta value. And that's the angle between these two vectors here. That's just a quick example. Thing that will come up is that, remember, if the angle between them, so let's say you had u and v, if the angle between them is 90 degrees, well then cos of 90 degrees, where we have v dot u, and this is in my worksheet, is equal to, well, this is, cos of 90 is 0. So therefore you get, this equals, then v dot u over u v. And remember, this is just a number, so we can get rid of it. So you get this. So if because they will ask on this, if your two vectors are at 90 degrees to each other, then you can just say that the dot product of those two vectors equals 0. Right. So that's the fundamental content. They can only ask you on pretty much these two things here. So understand those, and then you can move on to the question. Or even better, just start the questions and learn what you need to learn to answer the questions, which is that fundamental content. The ways in which they can ask on this fundamental content, is they can ask you using the scalar formula, like I said before. They can ask you on this, and they can ask you on showing when two vectors are perpendicular, which is when their dot product equals 0, which we said there. And they've asked that 28 out of 70 times. Out of 70 questions I've looked at, they asked it 28 times. In some manner, it might not be exactly that, but underneath it all, they're just asking you on that. That's it. And you'll see that by doing lots of questions. They can also ask you on basic vector arithmetic. This is like adding vectors, when two vectors are parallel, or subtracting vectors, looking at diagrams, this sort of thing. It's very, very simple arithmetic stuff, and you'll get very good at it the more and more questions you do. Finding the magnitude of a vector, asked 12 out of 70 times in those 70 papers, which we showed how to do up there, which is just, finding the length of the vector. Using the unit vector formula, again, we showed what that is up there, how you could do that. And then pretty rarely they ask you to find an area of something. So, they'll ask you to find, like, using half base times height, the area of a triangle. They'll do that pretty rarely. So I've got two questions here, which I'll go through, which will, basically, these two questions cover all these possible ways of the ways that they can ask. So this first one, show that the angle OAB is a right angle. Well, this is showing that two vectors are perpendicular. So they can write it in this form. So OA here equals 3, 2, -1. And OB here equals 7, -3, 1. That's the same thing. They're equivalent. And show that the angle OAB is a right angle. So we have to show that this angle, so this is OA, and it's very important to remember that in this scalar product equation, it only works when the two vectors are pointing away. So you can't have a vector pointing in and a vector pointing out. They have to both be pointing away, and the angle between those two vectors pointing away, that's when this equation is valid. So in this case, an angle OAB means an angle OAB. So that would be OAB, right? So that would be the angle between AO and the angle between AB. We have to show that is 90. You have to show that this angle here is 90 degrees. And the way you do that is you say, well, that means that, because we showed here, remember, that means that AO dotted with AB equals 0. Right? And the way that you would find that is that you need to find AO and you need to find AB. And this is where basic arithmetic vector arithmetic comes in. Well, we know that OA equals we know that AO equals negative OA. So that means that AO equals the minus of this, which is -3, because it's in the opposite direction. You know, OA is this way and AO is that way. -3, -2, 1. And AB, well, AB is just, if you think about it, if you have two vectors, let's say OA here, and we've got OB. Well, AB is just this vector here, A to B. And A to B, if you want to figure that out, is just, well, how do we get from A to B using these vectors? Well, we go AO plus OB, and you'll have to use that all the time. So your AB is equal to AO plus OB, which is, like we saw here, AO is minus OA plus OB, and if you want to be, you know, get it looking good, it's just this. So we have AB, and now we can find AB, and AB is just simply this, which is OB, 7 minus 3, 1. 7 minus 3, 1, minus OA, which is 3, 2, -1. 3, 2, -1. And we got 7 minus 3 is 4. Minus 3 minus 2 is -5. And 1 minus -1 is 2. So we have an AB and our AO. So for this angle here to be a right angle, that means that AO dotted with AB has to equal 0. So AO dot AB equals -3 minus 2, 1 dot 4 minus 5, 2. So this equals -3 times 4 is -12 plus -2 minus 5 is 10 plus 2. And would you look at that as 0? So therefore, there you've shown that the angle at OAB is at 90 degrees. Cool. The next part of it is pretty simple, but I'll go through it as well. So that included basic arithmetic and showing that two vectors are at 90 degrees. So this is at 90 as shown. So find the area of the triangle OAB. Well, that's just simple. The area of the triangle OAB, well, area of a triangle is half base times height. And the base is AB, the length AB, and the height is the length OA, or the length AO, same thing, right? So the area equals half base, which is the length AB. Damn, I shouldn't have rubbed out AB. Times the length OA. Well, we found AB before. AB was equal to OB minus OA, which equals 7 minus 3, which is 4, minus 5, 1 minus 2 is 2. So therefore is equal to the square root of 4 squared minus 4 squared plus minus 5 squared plus 2 squared, which equals 16 plus 25 plus 4, which is the square root of 45. And also OA magnitude, and this is all in the fundamental content, is 3 squared plus 2 squared. So this is 9 plus 4 plus 1. 3 squared plus 2 squared plus negative 1 squared, which is 13 plus 14, which is square root of 14. So therefore the area equals a half times the length of AB, which is square root of 45, times 14, which equals, if you put that in your calculator, square root of 45 times the square root of 14 divided by 2 is 12.5. 12.5 units. Units squared. So that again uses pretty much all of it, in that you used this, finding an angle using the scalar formula. You use basic vector arithmetic. You use finding the magnitude of vectors, and you use you didn't use that. So, and then this one, and you use the finding an area of vectors. And now this one will cover the other ways that they can ask. So we'll just go through that, and then we're done. And then all you need to do is just go through the worksheet that I got. So for this question, first part is find DF. So all you do is you just look on this diagram and you say, okay, well this is DF here. D to F in that direction. So DF, you just need to find a way from get to D to F. Well, you can see on this diagram, DF is just 4 down, which is minus 4k. Minus 4k. And then A to O is minus 6i. Because it's in the opposite direction of the unit vector I. And then plus 6k. So you got minus 4k, minus 6i, plus 4k. And that gets you from D to F. So your final thing is just going to be minus 6i. And then you've got no j component, so you can just write 0j. And then minus 4 and plus 6, you've got plus 2k. So that equals, write it in this form. I like to keep it in this form because I find it easier. So that's your DF. So that's done. Find the unit vector in the direction EF. Okay. Well, EF, to find this, all you need to do is just go, well, we need to find, so this is one that we haven't done yet. EF, to find the unit vector in the direction of EF, we need two things. We need the vector EF, and we need the magnitude of EF. So let's find EF first. Well, EF, again, we just do the same thing. If we look at our diagram, we can go down 4k, so it's minus 4k, minus 3j, minus 6i, and plus 6k. And that gives us, if we just simplify it out, we get minus 6 here, minus 3, and minus 4 plus 6, which is a 2. So that's our EF, so that's that part. And now from that we can then find, our EF magnitude, which is just the square root again. And you'll see when you start doing lots and lots of these questions, dude, they're just asking the same thing over and over again. We're finding the magnitude again. So this is just 36 plus 9 plus 4. Just do heaps of questions and you'll understand what I'm saying here. This is not like some sort of trick. Just do lots of questions and you'll see they're asking you on the same thing over and over again, just in slightly different ways. 36 plus 9 is 45 plus 4 is the square root of 49, which equals 7. So therefore, our unit vector, EF, is -6, -3, 2 over 7. So that's just, we can write it like this if you want. Make it look pretty. So that's your answer for that. Whoa. And finally, we can do this. I mean, we've already done one like this, but finally, using the scalar product, again, scalar product, to find the angle EFD. So that's EFD. So if we want to find the angle EFD, this is E, so theta EFD, we want to know what that is. E, that means we need the angle EFD, so F is in the middle here, so F, E, D. That means we need, to find this, because we know from our scalar formula, EFD equals, well, remember we have to have the two vectors going away from each other. So that means we need FD dotted with FE, FD and FE, divided by the magnitude of FD times the magnitude of FE. Well, FD, this is just, remember, FD is just minus DF, which we found above here. And obviously FE then is the same as minus minus EF. So what we do is we just plug this in. We say FD dotted with FE equals, FD is minus this, which is just 6, 0, minus 2. 6, 0, minus 2. Dotted with FE, which is just minus EF. And EF is this, minus 6, minus 3, 2. So the negative of that would be 6, 3, minus 2. Yep, just the negative of that. And that equals 6 and 6 is 36, plus 0, plus minus 2 times minus 2 is plus 4. So this equals 40. And then you can find, let's get a bit more space here. Then you can find, just work these things out individually. Because you know what you need. You need to find these magnitudes and the dot product. And that's it. And then you got it. So this is 6 squared plus 0 squared plus minus 2 squared. Minus 2 squared, which equals 6 squared is 36 plus 4 is square root of 40. And FE, magnitude, is just the square root of 36 plus 9 plus 4, which I'm pretty sure we worked out before. What was this? Square root of 40. So that equals square root of 49, which equals 7. So therefore our cos theta of EFD is equal to 40 divided by 7 square root 40. So finally, it's not hard, it just takes a little bit of time. The angle EFD is the inverse cos of this, which equals, if you just plug, so if you do 7 times square root of 40, 40 divided by that, and then shift cos, you get 25.4 degrees. 25.4 degrees. Right, and in those two questions, it has covered all the ways that they could possibly ask it. So, again, Very simple. Download the worksheet, go through and understand the fundamental content, which is very little. I've minimized it down so much. I've cut away all the shit and minimized it down for you. Look at that fundamental content and understand it. Go away, look at it. If you don't have much time, then don't worry, just jump right into the questions if your exam is like tomorrow or something. And then go through all of those past paper exam questions which I've done on my worksheet and got the answers for you. So just go through that and make sure you can do all of them, because all of these, there's 15 different exam questions and it covers pretty much every single way that they have possibly asked on the vector question in the last 5 years. So that's a really good resource. That's all from me, and I'll see you in the next video.